Okay, in this video we're going to talk about rational equations, which means we're going to talk about how just by me giving you the equation for g of x, the fraction equation, you're going to be able to identify and locate key characteristics like the x-intercepts or vertical asymptotes or undefined values like holes. We're going to talk about this in this video. Remember, again, like I always say, the one thing that never goes away in the math classroom is factoring. So in this case, we have to factor, and we have to look at our factors and see what we can talk about and think about with our factors. So let's jump right in with g of x. We have g of x equals x squared plus 4x plus 3 over x squared plus 2x minus 3. Take a second, please, and pause this video and factor these two polynomials, these two quadratic pieces. And if you forgot how to factor, check out my other videos on refreshing your memory on factoring. We have to factor these before we can ever go on. So if I jump into factoring the numerator here, we're going to get the factors to be x plus 3 and x plus 1. If you don't agree with that, again, check out your videos on factoring, and we'll go from there. So x plus 3 and x plus 1. Just to make sure we can FOIL it out in our head to see. X times x is x squared. I get 1x and 3x, which makes 4x. And I get 3. So I've got the right polynomial, the right factors. Same thing with our denominator. Again, I'm not showing you how to factor in this video. Go check out my factoring videos if you're confused on factoring. This video is just about what to do after you factor. So I'm going to factor x squared plus 2x minus 3. That's going to give me x plus 3 and x minus 1. Check it out to make sure. X times x is x squared. Negative 1x and 3x make 2x. And then 3 and negative 1 make negative 3. So I have the correct factored version. I'm going to notate that with g of x because I yell at you off about notation all the time, so I definitely want to make sure I notate. I want you just to pause for a second and look. What do you notice? Look at your factors. In your numerator, you have x plus 3 and x plus 1. The denominator, you have x plus 3 and x minus 1. Hopefully, the first thing that you notice is x plus 3 is in top and bottom, your numerator and denominator. X plus 3 can be removed. X plus 3 can be canceled out. X plus 3 is going to be a whole. Anytime you can remove something, a common factor, that's going to be where your whole is. So we take x plus 3 equals 0, set equal to 0 to our factors, and you get the whole is going to occur at x minus x is negative 3. So graphically, if you look at the graph of this picture on your calculator, or if you graph it by hand, you're going to know that at x is negative 3, there's going to be a whole. Why? Because you had a common factor in your numerator and your denominator. So what's left? Well, what's left after you take out the common factors is your x plus 1 in your numerator. So x plus 1 equal to 0. So something occurs at x is negative 1. Notice this was 0 in your numerator. If 0 is in your numerator, that's fine. That means your whole answer is going to be a 0, which means you have a 0, as in an x-intercept. Okay? What's left that we didn't deal with yet is the x minus 1. Well, the x minus 1 equal to 0 means x equals 1. There's something going to occur. Something's going to happen at x equals 1. Well, what's going to happen at x equals 1? Well, that's going to be a 0 in your denominator. Well, can you divide by 0? No, which means that you have a horizontal or vertical asymptote at x equals 1. So just by me giving you the equation, we know three very important things. I'm going to highlight these three very important things. The piece, after you factor, the common factor, what cancels, gave you a whole. In your numerator, what did not cancel, gave you a 0, an x-intercept. In your denominator, what did not cancel, gave you a vertical asymptote. So we know very important things about this graph at the moment. We know it's going to touch the x-axis when x is negative 1. We know when x is negative 3, there's going to be a hole there. And we know at x is 1, there's going to be a vertical asymptote. Very important. The only other bit of information we can get from this graph is going to be from this equation is going to be the y-intercept. And every year I get a little confused when it comes to this concept, because the y-intercept is the one concept that most students struggle with. And in fact, they shouldn't struggle with this concept. It's a very easy concept from Algebra 1 to be exact. When you're looking for a y-intercept, you know x is always going to be what? I'm hoping you're saying 0 to yourself. X is always going to be 0 when you're looking for a y-intercept. So if we go back to the very, very, very first equation, x is always going to be what? 0. So I'm going to take and I'm going to find g of 0. Well, I know at the moment that sounds like a lot. We're trying to find g of 0. Well, no, it doesn't. That just simply means that every single x in this problem is going to become what? A 0. So here I'm going to get 0 squared plus 4 times 0. Well, we know it's just going to be 0 plus 0. These two pieces are going to go away. So in your numerator, I'm just going to be left with 3. Denominator, same exact thing. 0 squared is 0. 2 times 0 is 0. So I'm going to get 0 plus 0, which is 0. I'm left with a negative 3. Reduce this. 3 divided by negative 3 is a negative 1. Therefore, your y-intercept is at negative 1. So graphically now, you know some very important things. You know that this function has a y-intercept at negative 1, vertical asymptote at 1, a whole at negative 3, x equals negative 3 and x is 1, and a 0 at x equals negative 1. How do we do this? Factoring. Factoring never goes away in a math class. If you factor and a common factor occurs, when you cancel that common factor, you know you have a whole. What is left in the numerator is your x-intercept. The denominator is going to be your vertical asymptotes. These two pieces here, x plus 3 and x minus 1, are undefined values. They cannot be 0. Whatever x values would make this 0 can't happen. So what we call undefined values or discontinuities would be your vertical asymptote and your whole. These two pieces here are called discontinuities, discontinuities. Okay, you can't have it. That's when the denominator would equal 0, which we can't do. Which cannot happen. Which is what causes these breaks in your graph. So it's going to end the first video here with all of this. It's kind of like lecture notes. If you catch out the second, if you check out the second video, maybe even a third video, depending upon the time limit, I'll show some more examples on how to factor to figure out these important things about your graph.